And let's see, what did we decide? Oh, wait a minute. Okay, so next Thursday, what's next Thursday's lab? Test. Okay, so remember how that works. If you have your calculations and your data sheet when you come take your test, then that's all you need to do. And actually, it's the same thing today. If they're there now, I'll take them as calculations data sheet. If they aren't there now, then you're going to just have to adjust. You have to tack on the experimental and the results and discussion along with calculations along the data sheet. Alrighty? Okay, so today's reaction is one that we've been talking about I should say the phenomenon we've been talking about in lecture. I don't think we've looked at the whole NaOH reacting with HCl, okay? But that's what you're going to be doing. This needs to be, if you end up writing your semi-formal lab report because you don't have the calculations to give me when you come take your test, this equation needs to be in your write-up. Basically, I'll go ahead and kind of write underneath the two reactants, your sodium hydroxide, that's NaOH, and your hydrochloric acid, that's HCl. In all cases, you are going with a 10.00 milliliter aliquot. Okay, in all cases. The molarity of your HCl is given on the bottle. It's 0.9007, I believe. 0.9001. Okay, so this is a case where you know volume and concentration of your HCl that you're going to titrate. 0.9001 molar. Okay, and in today's calculation, basically you are after the molarity of the sodium hydroxide solution that you guys are going to make. So I'll talk you through making your own sodium hydroxide solution. You have to find its molarity. Sodium hydroxide is going to be in your, this is my burette. Okay, sodium hydroxide is going to be in your burette. You are going to drip sodium hydroxide into your HCl solution, your 10 milliliter aliquot, and look for a pink color. Okay, so basically the amount of titrant that you drip in is going to be your volume. Okay, so volume from titration. Does that make sense? We kind of talked about this. So then basically when you do your trials, and you'll do at least 4 trials, when you do your trials, you'll have volume and molarity of the acid that's in your, it's the analyte in your Erlenmeyer flask. And you'll have volume of your sodium hydroxide, and you'll get to molarity of your sodium hydroxide that you are going to prepare. Okay, so that's kind of in a nutshell what we have going on. So looking at kind of the details of today, okay, you need to make your own sodium hydroxide solution. So what I have, and that kind of goes from left to right for me anyway. Down here is stuff that you'll need for your sodium hydroxide solution. It says, and you're going to make it kind of crude because then you're going to kind of come up with its molarity to 4 sig figs. Okay, so it says it says transfer 50 mils of stock solution. So I always like bases in the middle hood, acids in the first hood. So your NaOH is in the middle hood. I have a transfer beaker in there. Let's go ahead and be sparing with our NaOH so I don't have to try to scramble and make some more up. So if you could go ahead and just take the 50 mils you need, that would be great. I think this semester I'm going to do something kind of new. I'm going to have you guys use, if you don't have one, I've got extras, but use a big old honking beaker. Okay? And so basically I would, let's see, how would I do this? Well, your instructions are basically to take 50 and add water up to 500. So that's what, a 10-fold dilution? Does that seem reasonable? So what I would do is, since this is denser than water, I would get 450 mils of water in your big old beaker, okay, and then dump 50 mils in. Does that make sense? I always want to add what's most dense to what's least dense, so this will fall down. But I also have Listerine on, okay? So that's going to be your NaOH solution that you're going to use in your burette. Okay. All right. Step number 2, actually the following steps. Okay. I'm going to kind of, I don't know if you're going to like this or not, but I'm going to kind of talk you through a titration. And I'm going to project it just because I can. Okay? So, are there any questions about that? Okay. So the first calculation is to calculate an average volume of your 3 trials that are within 0.4 mils of each other. Okay, it says use only valid titrations. Okay, if you have one that it lies outside that 0.4, don't use it. So that's calculation 1. Calculation 2 is calculate the moles of HCl present. Okay, and that's using the volume 10.00 milliliter and the molarity 0.9001 molar. Okay. Calculation 1 then is now that, calculation 3 is now that you have the moles of HCl from calculation 2, use stoichiometry. It's really boring, one-to-one. Use the one-to-one stoichiometry then to get to the moles of NaOH. And the coup de grace, number 4 there, is to knock out what is the molarity of that NaOH solution that you prepared. So in that, you're just going to take the moles of NaOH that you got from step 3 and divide it by that average volume, which was calculation 1. Okay? All right. Goggles on, everybody. Good luck.